know me as your former president, I'm also a movie star, having been starred in Sabian Ryan's Private Act Pants Down, yeah. Today I'm here to narrate the story of Otto Hahn and all of his accomplishments. Over the course of the next 5 minutes, you'll be joined by a host of other celebrities narrating this story. Now let's talk about what Otto Hahn did for chemistry. Got these atoms flying out. Monica! Slow down, Monica!
Otto Hahn was born March 8, 1879 in Frankfurt am Main, Germany. When Otto Hahn was a young child, he always wanted to work in chemistry. At the age of 15, Otto Hahn began to do chemistry experiments in his downstairs bathroom. After his parents finally agreed to let him pursue his career in chemistry, he attended the University of Marburg in 1901, where he studied chemistry. After graduating from the University of Marburg, Otto Hahn in 1904 moved to London, England, to learn radiochemistry under Sir William Ramsay. In 1906, shortly after returning from Montreal to study under Ernest Rutherford, Otto Hahn met Lise Meitner at the University of Berlin, thus starting the relationship that would lead to advancements in radiochemistry and the discovery of nuclear fission. After moving to the Kaiser Wilhelm Institute for Chemistry, Otto Hahn became the head of the radioactivity department with the help of Lise Meitner. Here they studied radiochemistry and the effect it had on elements. After a woman interpreted radioactive recoil incorrectly, Otto Hahn interpreted it correctly in 1908. In 1914, Otto Hahn was conscripted into the German army at the outbreak of World War I. He was assigned to a special chemical weapons unit that tested and created chemical weapons that were used on the Western and Eastern fronts. In 1917, using radioactive methods of using isotopes to study the chemical reactions of non-radioactive isotopes, Otto Hahn and Lise Meitner discovered proactinium, the long-lived mother substance of the actinium series. Hahn further discovered uranium-Z, the first case of nuclear isomerism of radioactive kinds of atoms. He also collaborated with Meitner and Fritz Strassmann on the process of irradiating uranium and thorium with neutrons. It was for this discovery that Otto Hahn was nominated for the Nobel Prize in Chemistry. Otto Hahn discovered a new way to study the chemical reactions with radioactivity. Because of him, scientists are now better able to detect radiation and have a more fundamental understanding of the nuclei of an atom as a result of nuclear instability. Scientists can also apply the application of radioactive methods to chemical problems as well.
Hi. Now I'd like to introduce one of my friends, Robin Williams, so he can talk about nuclear fission. Yeah.
Oh, here I am, but no, I'm not. Oh, but I'm not staying over there, but I'm not staying over here. But I don't know what I'm saying. Oh, I'm in the middle. Oh, and the sky's falling, but I'm not, because I'm not in the ground. Oh, but the sky's falling, the pressure will be boils on, maybe not. Oh, okay. I guess today's topic is, boils on, no, it's not. Oh, okay, and then I guess it goes to, nuclear fission. Here we go, Otto.
Nuclear fission is the splitting of the atom as shown by this picture. The later pictures show the chain reaction caused by nuclear fission, which is a central part of a nuclear explosion. In the late 1930s, Otto Hahn, Lise Meitner, and Fritz Strassmann picked up on the research done by Enrico Fermi. Hahn bombarded uranium with neutrons in hopes to split an atom. On December 17, 1938, Otto Hahn concluded that the uranium nucleus had burst into atomic nuclei half the weight. This was the discovery of nuclear fission. Hahn had proven to the world that the nucleus could be split in two, and conventional knowledge disregarded nuclear fission had been thrown out the door. Hahn's creation paved the way for the nuclear age. Our understanding of the atom changed drastically when we realized that the atom could be split in two. Nuclear fission made scientists reevaluate principles that the atom was the smallest particle on the planet. Without fission, atomic theory might have been taking a different route towards ignorance. Scientists were also eager to grasp the energy potential of splitting of an atom. Nuclear weapons were made, as were nuclear subs and nuclear power plants. Hahn's discovery led to the greatest weapon of all time. After America dropped the atomic bomb on Japan, Hahn felt personally responsible and upset that he had made it possible for such a horrible weapon to be used. Actually, nuclear weapons are the second most powerful force of destruction. Here's the first. The Dean Scream!